Hey guys, this is your Unit 4 review video. Again, this unit was short, but it had a lot of information in it. So I'm going to try to run through it all very quickly. Again, if you need any help on any of these topics, go back and watch that video to help kind of solidify that information. The other thing is that these problems are coming from the PDF review that is in Google Classroom. So please feel free to go work it on your own and then come back and see how I got some of these answers. So the first lesson we did was the introduction. Basically, we were looking at finding patterns and then learning some new notations. So the first thing I want to point out to you is that whenever you're given some sort of explicit formula, it says like a sub n. Remember, this is like a y, and your n is like your x. So really what you're being given here, the n is your term number. So you're saying this is the blah, blah term, whereas this entire a sub n thing is the term itself. So it is the piece of the pattern. So if you want to think about this, we're used to seeing x comma y when we're looking at, a regular pattern or regular equation. This now is just saying that we're doing n and then a sub n. So we're defining a term, an a, whatever you want to call that, using the term number. So don't get those two notations mixed up. If you're looking for a term, you look for an a sub n. If you're looking for a term number, you're looking for the little n. Okay, so finding patterns. We did a lot of these finding patterns in the beginning, but then we were given some formulas and some names for those patterns. So the first thing that you might see is asking what kind of a pattern or what kind of a sequence are you looking at? Is it geometric, arithmetic, or neither? Remember, geometric sequences and series multiply every time. They have an R value, a common multiplier. So this first sequence went 6, 24, 96, 384. I can tell it's not arithmetic. We aren't adding the same thing every time. One of the fastest ways to tell if it's geometric is to take the second term, divide the first term, see what your number is, and then do the third term, divide the second term, so just the term before it, and you should get the same number. So this is geometric, and again, the multiplier is 4. If you look at this one, it's going 1.0, 1.3, 1.69, 2.197. This one is again geometric using the same pattern finding I did before. Again, you can tell it's not adding the same thing every time, so it's got to be geometric. Okay, I'm going to make a note over here. Arithmetic means adding every time. And that could be adding a negative, so it may look like subtracting. And then here, if I look at this pattern, it went up by 6, then it went up by 3, then it went up by 10. That's neither. Okay, it has to be going up by the same exact thing every single time in order for it to be an arithmetic sequence. So we'll look more at arithmetic in a second. Recursive sequences, I know this was a pretty confusing for a lot of people because it's a new notation and looking at it can be kind of tricky. Really, when you see something like this, I'm going to pull it over here so we can actually see it. This sequence is just saying whatever term in the sequence, I'm going to take the term previous to it and add 3. That's it. That's all it's saying here. So this right here just means the previous term. A sub n minus 1 is just the previous term. So if it had said a sub n minus 2, that would have been 2 terms before. If it said a sub n minus a million, it would have been the millionth term before. Okay, but that's all that notation is saying. It's just defining your sequence in terms of the term before it or the two terms, depending on what the sequence is saying. So for this, in order to find the second term, I need to take the first term, the term before it, and add 3. So I get 5 plus 3. That's it. Okay, to get the next term, I would take to find the third term, I take the second term and add 3. That's it. Okay, that's all you're doing every single time. You're taking a previous term and doing something with it. You may be multiplying or subtracting or doing other stuff too, but just take the previous term, do whatever operation it says. The next thing is the summation notation. Summation notation, again, this big sigma just means to add. Okay, it's saying do whatever's inside the parentheses or inside the sequence and add them all together. Okay, remember this bottom number right here? They may use K, they may use N, whatever. This just tells you what number to start on. So it may start at 1, it may start at 2, it could start at 0, it could start wherever, but all it's telling you is this is the one you're going to plug in first, and this number at the top, I don't know, 12. This number is going to tell you where to stop. So you're going to plug in every single whole number in between 1 and 12 for the summation into whatever the formula was. So if you look at this example right here, again, it said k equals 1. So I'm going to start by plugging in 1. So there's the 1 right here. And right here, there's actually 2 k's in this just to make it harder. And then I'm going to move on, calculate that, move on. Then I'm going to add the next part. So it's going to be 2 and 2, and then 3 and 3, 4 and 4. Again, I've just plugged in every whole number until I got to that stopping number on the top. Same deal here. Maybe it's a little easier to see here because I'm going to plug in 2, and then I'm going to plug in 3, and then 4, and then 5, and then 6, and just add up that sequence. So this tells you what you're plugging into. These tell you what you're plugging in. Okay. Again, make sure you know the process for this, not just a shortcut. You want to make sure you know how to find the expanded summation notation, because I can guarantee they're going to ask you about that. All right, so that was the intro. Let's talk about specifically arithmetic sequences and series. So the first thing we talked about were the sequences, which dealt with this a sub n formula. Remember, this is your term. This a, or a sub 1, is your first term. You're always going to use your first term in the formula. This is your common difference. Remember, that's what you're adding or subtracting every time. It's kind of like the slope of the equation. And then this, again, is your term number. So to find the 8th term in the sequence, you would need to use the number 8 here. Okay, so that's the nth a sub n formula, the nth term formula. So if you were asked to find something like the 60th term, you can just use that formula to make your life easier. Because yes, I could continue this pattern on for 60 terms, but it's going to take me a long time. So the first thing you look for is your first term, which was 26.2. Then you find your common difference, which again, if you can't find your common difference off the top of your head, you don't see it, you just take one of the terms. So if you took 29.9, subtract the term before it. Okay, that gets you 3.7. And you can check again if you want to find a different one. They did tell me this was arithmetic, so I automatically knew I could use this formula. And then it's just plugging in 60 for n. So then you solve that out. Again, put in your calculator. Please don't miss this because you try to do it by hand. This is kind of the same idea. You're still going to use the a sub n formula, but you're going to use it a little bit differently. The first thing it says is you want to find the number of terms. If you want to find a number of terms, that's an n. You need to solve for n, not for a sub n. So the first thing I look at here is I make sure it's arithmetic. Every single time it's adding 5. That's good. So now I'm going to plug into this formula. I know that my first term is 3. My common difference was 5. I don't know n, but I do know this guy is the nth term. So I'm going to plug in 73 and then solve it for x. Well, I guess it's n here. Please be careful. Use PEMDAS. A few of us were trying to add 3 and 5 before, and no, bad news bears. Okay. And then finally, one that's a little bit trickier because they use letters. You can't just see the pattern off the top of your head. They said in this sequence, I told you it's arithmetic, so you already know you can use the arithmetic formula. They gave you the second term and the third term and said find the 11th term. So the biggest thing that you're going to have to do here is figure out what is my common difference. How did I change to get from 2 to 3? Well, I went from 4x's to 6x's, so I added 2x's. And I went from 1y to 5y, so I added 4y. So now this entire thing is my common difference. So this would be the formula I would use normally. And I'm going to plug in the crazy stuff here. So this is my first term, 2x minus 3y. And I found that because I took away this 2x, right? I took away 2x and then I took away 4y. I went backwards in my common difference. Then I took my common difference, multiplied it by 11 minus 1 or 10, and then just solve this out. And again, you could totally brute force this and figure out what that is based on, just keeping the pattern going, but it's going to take you a while. Okay, a series. Remember, a series is just adding all the terms of the sequence up. So there are 2 separate formulas for an arithmetic series. They both will get you the same answer. This one is useful to use when you know the last term. So if you know the last term of whatever pattern you're adding, great, use this formula. This formula will always work, and the letters still mean the same thing. This is the number of terms. This is the first term, the common difference, and then again the number of terms. This one is the number of terms, the first term, the last term, and then that's 2, surprise. And so the S tells you that it's adding up those terms. Again, these are partial sums for arithmetic. We can't add the whole thing up. So they said, here is your formula. I was like, I think I've seen this one, maybe not. and you want to find the actual sum. So you want to figure out what that number is. And of course, I keep saying this, but you can always just try to type this into your calculator. But again, it's going to take you a while. So these problems have two separate steps. The first step is you need to figure out what term this is. You need to go do what we did over in number 4 and tell me what term, how many terms am I adding up in order to get to this 39. So you plug in, you find that that was 10 terms, and then now you can plug it into one of the series equations. This one is the easier one because you know the last term. The other one will also work, but now you know that it was 10 terms, and then you're just going to plug into your formula. Again, you have to do two separate steps on these types of problems. Then we have the beastly question, like number 10, how many terms of this series must be added for the sum to be 3,402. The first thing you want to do is make sure what type of sequence it is. It is arithmetic. You're adding 5 every time. And so then you're going to plug into one of those formulas. Again, I don't know the last term, so I'm going to use the longer formula. So I know what my S sub n is. I want the sum to be that big number. I don't know what n is, though, in this case. So I'm going to leave n in my formula. My first term is 7. My common difference is 5. And again, I have to leave this term in. So this one solved a little bit further down. But remember, you can plug this into your calculator just like this. You just need to move everything to one side of the equation. So if you were to type this into your calculator, again, you need to subtract 3,402, kind of like how we did here, and then go look at the table in order to find where you have the x that's a positive and a whole number. You could also use the numeric solver if that's something that interests you. But again, this one takes a little bit of finagling in the calculator. Again, I'm testing you on these sequences and series stuff. I'm not testing you if you can solve a quadratic. So use your shortcuts in order to find the answer to this. Again, you want your x to be a positive and whole number, and use whatever method makes sense to you to solve this equation. And we kind of talked about using the highlighted one and just subtract 3,402 from both sides. Okay, the next type of sequences are geometric. Remember, geometric just means that we're multiplying by the same thing every time. So the multiplying every time may look like a division. Okay, it could be getting smaller, but if you're dividing, you're just multiplying by a fraction. So this is the formula that we use. We have the first term times the common ratio and then to the n minus 1. So if they ask me to find the nth term, remember nth term just means find the formula. So we want a sub n and the 10th term, so the nth term and the 10th term. So when you plug in to this, you would just go ahead and say my first term is 4. My common difference is whatever it is, and then to the n minus 1. Again, if you can't see the common difference off the top of your head, common ratio, you can't see that it's multiplying by 3. Don't worry, I can't sometimes. Take one of your terms and divide it by the term in front of it, okay? Then again, if you want to check to make sure it's geometric, take one of your terms, divide it by the term ahead of it, and that would tell you what your common ratio was. So then if you wanted to find the 10th term, just plug in 10 into your equation. Done. Some of these get very big. This one says find the first term in a geometric sequence whose common ratio is 3 and whose 8th term is that big number. So again, I listed out what I know. And then if you think about this formula, that's what you're going to do. You're going to plug into this first formula. I know what a sub 8 is, so I'm going to plug in 8 for n. And in this case, my 8th term is 8,748. So I'm going to say 8,748 equals a times 3 to the 8 minus 1 is 7. And then it's just an equation to solve. Okay, get some numbers out of it, divide, you good. This not last one, but this one says how many terms are there in this sequence? So again, they give you the sequence and then they give you this final term. Your goal is to figure out how many did I have to list in between those dot, dot, dots. So again, we're still using the same formula. We're still using a sub n. They're asking for terms. They use the word terms. So my first term is 1. My common ratio is 1/2. Again, you're going to take one of the terms, divide it by the one in front of it. So every single time I'm dividing by 2, which is the same thing as multiplying by 1/2, and then I plug it into the formula. So I have 1 over 1,024 equals 1 to the 1/2 times to the n minus 1. There's a couple of ways to solve this. The easiest way to solve this is to use your knowledge of exponents and knowing that 1,024 is in fact a power of 2. So I could rewrite this as 1 over 2 to the 10th power, and then I can just set the exponents equal to each other. If there had been a coefficient in front, you would have had to divide both sides. So make sure when you're using this particular method, you do math, enter, enter to get your fraction if that helps you see your exponents better. But that will help you like figure out if it is a power of 2 or whatever. You can also do the log base, do whatever method made sense for you from the log unit. This last type of one from the sequences part of the geometric is for what real value of C will 6 to C be consecutive terms in a geometric sequence. So they've told you here that these are geometric. So I know that whatever I have, if I want to find the common ratio, if I had 2 over 6, the second term divided by the first term, and then I had C over 2, those two things should be equal. So now this is just an equation where I can cross multiply and solve, and I might get a fraction. It's okay. But again, I've just taken one of the terms, dividing it by the term in front of it, one of the terms, dividing by the term in front of it, setting them equal. Okay, series, this is when it gets a little bit trickier because you have multiple different types of formulas that you use here. This first equation, notice it has an n underneath. This means that it's a partial sum. You are only going to be adding up the number of terms they say in here because they're going to have the first term, the common ratio, the number of terms, and here's the common ratio again. So if you're finding the sum of the first 8 terms of this sequence, again, you're just going to use this a little bit longer formula, but because it says S sub n, that will get me just the first 8 terms. So again, I found what R was every single time I'm multiplying by 1/4. So to find the the sum of the first 8 terms, I would put the first term multiplied by 1 minus, so that's kind of hard to read, the common ratio to the 8th all over 1 minus 1/4. Again, this is in fraction form. This is it in decimal form. So I just typed all of that into the calculator exactly like it looks on my paper. I used alpha y equals. Y'all know how to use your calculator. This other formula is the infinite sum. So this is to check, or once you've checked if a series is converging or diverging, you can use this formula to find the sum of the entire series. So remember, in order for a series to converge to one number, R, the common ratio, needs to be a fraction. It needs to be like this. Sorry, I messed up. So technically that 0 wasn't necessary, but whatever, it's a fraction, okay? It's going down by the same amount every time dividing, okay? So it doesn't matter if it's positive or negative, it just needs to be a fraction. So if I look here, again, if I can't find the common difference, just divide the second term by the first term. And this one says that yes, my R is -4/7. So since that's less than 1, the series does converge, and I can plug it into this formula to find what it converges to. So if I add up all the terms in that series, I would get 2/11. Okay, if I look at letter B, every time I'm multiplying by 3, which means it's getting bigger and bigger and bigger. So if I added up all the terms in that series, it would just be infinity. It'd be a really big number, so that we say that the series diverges. This last one, it's a little bit harder to see because there's an A in it every time, but my common ratio here is 1/3. So it is a fraction, so I can use this formula, the S equals A over 1 minus R. That just means I'm going to have some letters left in my answer. That's okay. So I'd have -A as my first term, divided by 1 minus my common ratio, which is 1/3. Then I can simplify that down to -3/2 A. Okay, so again, you have to look and see if your common ratio is a fraction, and that means that you can, in fact, take an infinite sum. Alright, the last thing in this unit was binomial expansion, which I know can be kind of tough. It just has a lot of pieces to it. So the first thing we talked about were the combinations. This is combination notation. Again, you say n choose r, and then you can plug into this formula with factorials. So if you were given evaluate this particular combination, you could plug in all that stuff. Or you can use your friendly calculator, press the math button, you go over to prob or to perb, so I think it's like 2 check marks next, and then you go down to NCR. You'll replace your N with 15, your R with 3, and it should pop out your answer for you. Again, your bigger number should always be first, and then you would get that. You can also use Pascal's triangle, but do not recommend. That would take you a while to write it all out. Okay, the next thing is actually using the binomial theorem to expand binomials. Again, a binomial is just something like a plus b power of something. Okay. Cool, I got an email. So this is a binomial, and in order to expand it, Before we used to have to FOIL. We used to have to be like a plus b times a, or yeah, times a plus b times a plus b, and we'd have to use a box, we'd have to use FOIL. It would get kind of complicated. This is the shortcut method, and I know sometimes it doesn't seem like a shortcut because it looks really long, but it will help you find things like coefficients of middle terms, things like that. So again, the summation notation says you're going to add up all your terms. So if you notice in my expansion over here, there are plus signs in between. Okay, there are plus signs all in between here. However, inside each of, or between these plus signs, I guess, these are all individual terms that you end up multiplying together. Okay, so you multiply in between the plus signs, but you're then adding all of these terms together. So in the end, you see that they're, well, I guess it's a minus, but a minus, plus, but they're all being multiplied together. Okay. Notice in the summation notation, you start at 0. So you do have to plug in 0 first. So we're going to take my exponent, goes in the top of my combination. Then I start at 0. And then as my combination notation goes up, I go until I hit 5, choose 5. Okay, we go until that exponent number. Then when I look here, I'm going to use each of these pieces, and then I'm going to raise them to a power. So the first one, these two always will match. So right here, well, I guess I got to keep going. Those two numbers always match. So if there's a 0 here, there's a 0 on the second piece. So there's a 1 here, there's a 1. Notice those two match. Well, it should say 5, but my bad. Can't read it. And then the exponents, so what I have written in blue here, should add up to be the top number. So 5 plus 0 is 5. 4 plus 1 is 5. 3, 2, 2. So it's just a big pattern. Then you simplify down. We just talked about how you can find 5, choose 0, 5, choose 1, 5, choose 2, so on and so forth. And then you will have to use your exponent rules. So we would distribute this 5 to the 2 and to the x. So that's where 32 came from. And then again, you're distributing each of these things, and then eventually you'll multiply. Okay, so that takes a little bit of time to do. However, it's much faster than if I tried to multiply that whole thing out. Then they might ask you to find specific terms within the sequence. So to find a fourth term in this particular expansion, you could do what we just did and count out to 4. Do not recommend. So the first thing I know is that I'm always going to write out this. Like honestly, this is my method to solve this type of problem. I do all my parentheses. I look and I see, okay, that's 8. I'm 8, choose whatever. Then I'm going to say, sorry, what my expansion terms are. So I have 4x and I have negative 2y. And then I'm going to worry about my exponents. So the fourth term, you're always going to do one less, because remember, you start at 0. So it would be 0, 1, 2, 3, 4. Okay, so I'm going to start one less. So that's 3 and minus 1. And then these two are going to match. And then I know that these two pieces are going to add up to whatever my top exponent is. So 3 plus 5 is 8. And now I can just simplify down. Okay, that's honestly the process I use. I fill out the pink part, then I worry about the blue part, and then I do the orange part. So 8 choose 3 is 56. 4 to the 5th was 1024. X to the 5th was x to the 5th. Negative 2 to the 3 was negative 8. And then y cubed is y cubed. And then multiply these numbers together. Okay, same deal down here on this guy. It says write the term that contains x to the 6th in this expansion. So I did it the same way. I did the pink part first. So I would say that it was 10. I plug in x. I plug in 2y. Then it asked me which one contains x to the 6th. Well, that's pretty easy. I'm just going to put a 6 on x. And now I know that these two things add up. So 6 plus blank is equal to 10. So 4. And then this 4 will match. And then again, same process there, multiplying your terms together. So the coefficient of this would be 3,360. And that is Unit 4 in probably a pretty long nutshell. I hope that helped you out. And again, you can feel free to skip or go back to that lesson that makes sense. Again, the answer key for this should be posted in Google Classroom if you wanted to work out a blank copy and then check your notes on it. But good luck.